So then the last one is if you rotate them 270 degrees. So that means like, so from here to here is 180. So that's another 90. So that's going to go over here. So what's this point going to be? So it's going to be the same, it'd be the opposite of the y, because we'd have to go back 4.
Mrs. Corber, couldn't that
So
just be
negative 4, 3. So that, and then just regular x.
Couldn't that just be negative 90 degrees?
And then that's a really good point. That brings up the next
90
thing.
degrees counterclockwise.
So this is clockwise, clockwise. And then what he brings up is a good point, that 90 degrees clockwise is the exact same thing as 270 degrees counterclockwise, which is the same thing as 90 degrees counterclockwise. Yes?
How is it negative y if the negative y is the x?
So then here's the x and y right here
The 270.
for the 270 degrees. So here's our original x and y. And if I rotated it, so let's see, where am I going to put that? So here's my dotted line. So I take this 3, 4, and I move it all the way around to here. So that's 270 degrees. That new location is negative 4, 3. So then see so,
It's positive.
so 3 is the y on this one, correct? 3 is the x on this one. So you take the xy, whatever the x was, you put it in the y spot. So that's why we had 3 and then 3. And whatever the y was, you make it opposite. So our y right here is 4, so right here it's the opposite of 4, which is negative 4. Does that help?
Yeah.
Okay. And I think it makes more sense when you can actually see the picture of it all happening. Okay. So that is for rotations. Those are just some general rules. They may help, they may not help. Last part, so we did translations, rotations, the last part is reflections. So I would put that right here. Reflections. So there are reflections that you can do across other lines, but these are just some general. So again, these are only if it's at the origin. If you are rotating it about some point that's not the origin, you can't use those. But for reflections, which is what we're working on now, we're going to talk about reflections only across two certain ones. So if it's across the x-axis, so then we take our xy, our normal point. If it's across the x-axis, if you take a point and reflect it across the x-axis, the x stays the same, but the y goes opposite. And as an example, I'll put it up here on this graph. So if I had this point right here, so that's the point 3, negative 1. I mean negative 3, 1. Gosh. Negative 3, 1. And I reflected it across the x-axis. So notice it's still back at 3, but now it's negative 1. Do you see what I'm saying? So now it's just the x stays the same. X-axis means the x stays the same and the y goes opposite. If it's across the y-axis, our x, y goes to. So y-axis, the y stays the same and the x goes opposite. So if we take this same point that we started with and reflect it across the y-axis, then it would be 3, 1. So again, the y stayed the same, now the x is opposite. And those are just for those. Oftentimes you will have reflections that happen across lines that are not the x and y axis. But the cool thing is the distance from the figure to the line stays the same. So I'm going to draw a really quick drawing of this. If I had, let's do that star again. If I did that star, then the distance from here to here, and this was my line of reflection, this distance on this side is going to be the same distance as over here. This distance right here will be the same distance right there. And then all these distances, if you connect the new one to the old one, those are all perpendicular to the line of reflection. So let's see if I can do that. Dun, 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 something like that. Anyway, so all those distances would be the same. So that's basically the main things for reflections. Yeah, these kind of like, they focus on one point because this reflecting it is really much easier if you do it with just one point. And sometimes it helps if you need to reflect an entire figure around a plane. I start out by writing down what the figures were. So like, for example, if I had a triangle and I didn't actually have to draw it, but if I had triangle A, B, C, and A was at the point 1, 2, B was at the point, so that would be like 1, 2. Let's say B was at the point 3, 3, sure. And C was at the point, it wouldn't make a nice triangle, it would be a funky triangle. Let's do 3, 1. And I rotated it. Let's say that I rotated it 90 degrees counterclockwise. Which one of those things that we just took notes on would we follow? Yeah, so we're going to do negative y and x. So that's what we would do. So our A prime, and I personally prefer to write it down like this, because if I just try to like do it without writing it down, I make mistakes.
I thought that it was negative, I thought that it was y negative x.
But this is counterclockwise, which is the same thing as 270 clockwise. Yeah, so just watch out what it says. So then that means we're gonna take the y and make it opposite. So what's the opposite of our y? Negative 2, and then just the x. And B prime is gonna be negative 3, 3. And then C prime is going to be negative 1, 3. So then you would graph those points. Let's see. And then it would ask questions like, they're going to give you 2 pictures and they're going to say like, what has to happen to make it all, like to get one figure, to like figure A to become figure B, or figure C to become figure D. And they're kind of tricky, but it's easier just to explain on their own. Okay, so that's the end of this.